This video is for Algebra 2, and we are looking at transformations of the rational parent function. We've been talking about transformations off and on all year. We know that if you change the number at the end, it's going to move it up or down. The number trapped with x, left or right. At the front, if you put a negative, it's going to flip. All these rules are the same. Now, to be trapped with x, when we talked about a quadratic, that meant it was in parentheses with it. Okay? For a rational, it means it's in the denominator with x. So to be trapped with x, it's in the denominator. So your horizontal changes are going to be numbers down there with the x. So this would be considered kind of your parent function, what we're working with. If you have a number at the end, we know that's a vertical translation. If it is a positive, it's going to send it up. And if it's a negative, it's going to send it down. If we have a number trapped after the x, remember it's going to be a horizontal move, and it's going to do the opposite of what you would expect. So if it's plus, it's actually going to go left, and if it is minus, it's actually going to go to the right. We know that if you put a sign in front of it, a negative in front, that is where you would find your flip. Sometimes they'll put the negative up in the numerator. We know that if you put a number in front of the whole thing, that's going to make it get narrow or wide. And we know if you have a number trapped down here with the x, that that's going to make it wide or narrow. So that's a summary of what can happen and where you're going to look for this stuff. So, vertical stretch or compression or reflection. Those are the three things that can happen. Okay? It is going to stretch if a is greater than 1. In other words, if you have a bigger number than 1 up here in the top, it's going to have a vertical stretch. It's going to get steeper. You're going to have a compression when a is between 0 and 1, which means that it's a fraction. And it's going to reflect if a is negative. Once again, that negative might be with the a and it might be in front of the whole thing. You're going to have a horizontal translation if you have a number trapped down there in the denominator with the x. And as we said before, these work the opposite of what you would expect. And so it's going to go to the right when it is minus a number. And it's going to go to the left when it is x plus a number. Your vertical translation is going to move up when you have plus a number at the end, and it's going to move down when you have minus a number at the end. So they're going to give you a graph and say, okay, what's the new function rule? In other words, what's the new equation? We'll look at your graph and see what happened. Okay, did it move up or down? Well, no, because my horizontal asymptote is still on the x-axis. Did it move left or right? Yes. My vertical asymptote used to be the y-axis. Now it's over here at 3. So it went to the right 3. So then you stop and think, well, if it's right, that's horizontal, it's trapped with x, it does the opposite. So it's 1 over x minus 3. So if you look at this next one, did it go up or down? Yes, it looks to me like it went up 1. Did it go left or right? No. Did it get narrow or anything? The way you're going to check that is going to be difficult, but most of them, if it's a change, it's pretty obvious what happened. And so there is no change here. If it went up 1, you got to add 1 at the end. So it's 1 over x and then plus 1. If you're adding it at the end, it's not part of the fraction. It's at the end of the whole equation. So looking at this one, it looks to me like it went left 1. It also went up 2. So the left 1 makes it 1 over x plus 1, and the up 2 makes it plus 2 at the end. Okay, most of the ones you're going to see here are going to be reflections or horizontal moves or vertical moves. They're not going to be compressions and expansions, okay? Going to the back. First of all, they want you to set your window. I'm not overly concerned about you setting the window because I really think you can do this without using a calculator. okay? If you look at this, what happened to it? Well, the only thing different from the parent is that 2, and we said the bigger that number is, the more narrow it is. So all that happened there is we got narrow. Looking at the next one, we have a negative, so we have a flip. We have a number bigger than 1, so it also got narrow. Then we have 1 over x minus 2. That's going to send it to the right too. Rather than trying to match these to the graphs, because it's confusing the way they've got this made, I just want you to be able to list what happened. Okay? So looking at this one, we have it trapped down there with the x. It's horizontal move. It does the opposite. So this one would go left 2. 4 over x, they took the number at the top. It got bigger, so it's going to get narrow. We added 4 at the end, so the whole thing is going to go up 4. We have a negative, which makes it flip. We have a number that's bigger than 1. Remember, don't look at the negative, just the number. 4 is bigger than 1, so it's going to get narrow. We have a minus 4 at the end, so it's going to go down 4. We have a negative, it's going to cause it to flip. We have a plus 2 at the end, so it's going to go up 2. We have a negative, which is going to make it flip. We have a minus 2, which is going to send it down 2. We have a negative, which is going to make it flip. We have a 4 trapped down here with the x. Horizontal move does the opposite, so it's actually going to go to the left 4. Last one, we have a negative, which is going to make it flip. And we have a 4 trapped down there. It's x minus 4, which sends it to the right 4. Once again, I'm not worried about you being able to match it to the graphs because they've got those graphs turned several different ways. I needed you to be able to look at this and identify what happened, okay? Because that's what you need to be able to do on your assignment. If you have any questions, call me over.